Hi everybody. Hello, I am your tutor from the mytutorsonline.com, and I'm your physics expert here, the physics tutor. As per the schedule, dear students, today we are going to start with the topic, and that is a very important topic, right? That is known as the photoelectric effect, right? It's a very most important topic in the physics, right? And it is very useful, right? For your numerical portion and even the competitive exam also. In board exam also many questions are asked from this topic. So let us start this topic known as photoelectric effect, right? Okay. Now, see, the photoelectric effect, dear students, is one of the outcomes of the very famous theory of physics, right? Okay, very famous theory of physics. And what is that theory in physics? That theory in physics is known as what? The dual nature theory, right? Dual nature of light theory, right? Okay. So many scientists believes in the dual nature theory. The many physicists actually believes in the dual nature theory as such. Now, what is basically the dual nature theory is, right? What is that? And that is a very important theory. So let us first understand what is the dual nature theory. See, when you are saying the dual nature theory, it means there are two important verticals in this. One is what the light is having the two natures particularly. Okay, and then what are the natures of the light? The first nature of light is not known as what? The wave nature, right? Okay, and the other nature of the light is known as what? The particle nature. Okay, so when you are saying light is a wave, what does it means, dear students? It means what? That light is traveling in the form of the electromagnetic wave. This you already know, right? Light travels in the form of which wave? The electromagnetic wave. Okay. And when you are saying particle nature, that means what? It travels up in the form of what? The small particle known as what? Photon. It travels in the form of what? Photon, right? Okay, so these two are the very important fundamentals, right? One is the electromagnetic wave, and other is the photon. When you are saying electromagnetic wave, that means what? Light consists of two fields. One is the electric field, and the other one is what? The other one is known as the magnetic field, right? So let us understand these two things, right? By a very important presentation, right? Very important thing, right? For that, we will have the study of the two scientists here. One was the Holox, another was the Leonard. With both the scientists we have the study, right? So both the studies we are going to do here, right? And those are very important one. So the two scientists, one was what? One the name of one physicist was Holock, right? And other was Philip Leonard, right? These two scientists have first proved this photoelectric effect experimentally. Now before this, there is a small explanation done by the very famous physicist Max Planck. What Max Planck have said? Max Planck have said what? That the total energy which we receive from the light energy is always proportional to its frequency, that is nu, right? That means E is equals to what? E is equals to h nu, dear students, right? Okay, E is equals to what? E is equals to h nu. Now what is nu here? Nu here is the frequency of the light, and h is basically the Planck constant. This you already know. The value of h is what? 6.62 into 10 to the power of minus 34, right? Joule seconds, right? This you already know, right? Okay, now let us study the Holox and the Leonard's experiment which they have done for the photoelectric effect, dear students. When we say photon, right? Okay, photon, what does it means? Basically, this is the smallest particle of the light, that is known as the photon, right? Okay, and one of the a very important thing associated with the photon is what? One is the frequency of the photon, and another is what? The wavelength, right? That means when you are seeing frequency, wavelength, and photon, all these things, that means light is possessing the dual nature, right? One way is when we say photon, it is, that means what? We are assimilating the particle nature. And when we are saying frequency and the wavelength, we are assimilating what? We are assimilating the wave nature of the light also. So both the natures are combined here, right? But there are the physicists like Einstein who have only considered the wave nature of the light. They have not considered, so they have only considered the particle nature of the light. They have not particularly insisted on the wave nature very much. So this we are going to study later on. First of all, let us study the Holox and the Leonard experiment. So the experimental setup of the Holox and Leonard was like this, dear students. I will draw it on the board for you people. So the experimental setup was like this, dear students. This was a they have taken a vacuum tube, right? Okay. Here was one. There was one crystal here. From this crystal, the light can enter. This is known as a quartz crystal, right? Okay. Now, why they have used the quartz crystal? It's a very important question. I will tell you why they use the quartz crystal. They have made one electrode here, right? This was of the metal plate. This was a metal plate here, right? Okay. And they have connected this to the negative potential of the battery. That means this was cathode, right? And the positive they have connected to the other side of this tube, right? Here. This was what connected to the positive. That means this will be what? This will be anode, right? Okay. One thing more they have done, that why they have this quartz crystal is used. Quartz crystal is used to capture the ultraviolet light. Okay, quartz crystal is basically used to capture the ultraviolet rays. That is the use of the quartz crystal. Now, what they have done, they have incidented some light energy through this quartz crystal, and that light energy was incidented on this metal plate. So, what is basically the photoelectric effect? What is the meaning of the photoelectric effect? It means what? That when the light energies fall on a metal piece, okay, whenever the whenever light energy, right, falls on the metal plate, falls on metallic plate, right, then what is going to happen? Then electrons gets emitted, electrons gets emitted from the plate. Okay, that means when the light energy will fall on this plate, this metallic plate, the electrons from here, from this plate, the electrons are going to go towards the other side, that is known as the cathode, also that is known as the anode, right? Okay, from cathode the electrons will go towards the anode. Now when the electrons are going to travel, then what is going to happen? Some small amount of current, I repeat, very small amount of current will generate when the electrons will travel from the cathode to anode, right? A small amount of current is generated. That current will be in the microamperes, dear students. And this current, which is known as what? This current is known as the photoelectric current, right? So in the nutshell, I will repeat this definition. What is the definition? That whenever the light energy falls on the metallic plate, then, right, some electrons, okay, gets emitted from metallic plate, right, and they travel with some kinetic energy, right, with some kinetic energy. So minute amount of electric current is generated, minute amount of electric current, right, is generated, right? And this current, that is known as what? Known as the photoelectric current, known as photoelectric current, right? And this effect is basically known as what? This effect which is produced, okay, the entire effect, when you are falling the light energy on the quartz crystal, the quartz crystal will capture only the ultraviolet rays. These ultraviolet rays will fall on the metallic plate, electrons gets emitted from the plate, and the electrons are going to travel from the cathode to the anode. Then this photoelectric current is generated. So this entire effect, this entire process is known as what? This entire process is known as the photoelectric effect, right? This was the experiment which was done by the very famous physicist known as a Philip Leonard and Horrocks, right? Okay, a very famous experiment. Now, the important part is what we have read, that what is the experiment, but we don't know, dear students, that what is the physics involved in this. This is just the experimental process, that okay, we are converting the light energy into the electric energy. That is one of the case, right? One of the principle. But here the underlying principles of physics, that is what we have not associated: the frequency, wavelength, right? Okay, electric potential, the electric current. The relationship is not established yet, and the physics is not complete until unless we will establish the relationship of these physical quantities together. So in the exam, whatever exam you are going to give, that is whether you are going to give the NEET exam or IIT exams, this photoelectric effect topic is very important. Why? Because 2 to 3 questions are asked from this topic. Even in the board exams, many questions are asked from this topic. This year it is actually marking up the 6 marks exactly, because the 30% course is already the CBSE is already said that 30% course is not going to come. 70% syllabus is also there, already there. So from that is why the this photoelectric effect particularly is holding the more marks, right? इसमें ज़्यादा marks जो है, there's more marks it is involving. So let us study the mathematical interpretation of this particular statement or the law which we or the process which we have studied right now. So what Horrocks and Leonard have concluded, okay, they have concluded number one thing is what they have concluded, that the intensity of photoelectric current, right? Photoelectric current is directly proportional to number of photoelectrons emitted. That means more photoelectrons are going to emit from the metallic surface, more photoelectric current is going to produced. Okay, that means what the if you draw the graph between the photoelectric current, right, on one axis, and on the other axis you are going to create the intensity of photoelectrons, then the graph of this will be always and always the straight line. Okay, this kind of graph is going to be there, right? Second thing, with the Horrocks and Leonard have said, what they have said, that the entire energy, the h nu, the entire energy which is received, suppose this is the metallic surface you have, this is the metallic surface, and on this metallic surface you are going to receive the h nu energy. This is the light energy you are going to receive by according to the Planck. This entire energy is actually converted into the kinetic energy of the electrons. This they have said. Now this statement is totally false, right? Why this statement is false? Because there should be certain amount of energy which must be required to eject the photoelectrons also, for the ejection purpose. Suppose the h nu amount of energy is coming, right, okay, on the metallic surface, and then you are saying the electrons are emitted from the metallic surface. So in between there something is there, right? The Horrocks and Leonard have said that energy is coming and the electrons are getting emitted, and the process is over. No, this is wrong. Why? Because the energy is coming to the metallic surface, electrons are emitted, they have the kinetic energy, it's fine, but in between there should be there's something should be there, some energy should be there which must be required for the ejection also, for the electrons from the metallic surface. So this entire mathematical interpretation of this particular photoelectric effect statements and the laws was framed by the very famous Nobel laureate and the most famous physicist, okay, theoretical physicist, Albert Einstein. In 1921, Albert Einstein has got the Nobel Prize. He was declared the Nobel laureate, okay, on his particular theory of the photoelectric effect, which he has already given 15 years back, since the 1921. In the 1905 or so, he has published 2 papers, and out of that, one paper was actually showing the entire calculations related to this particular theory, right? However, the one of the physicists who already discovered this, that is a this scientist Philip Leonard has got the Nobel Prize before the Albert Einstein. 14 years back, before the Einstein, he has got the Nobel Prize for this particular theory. But unfortunately, the theory, which was the mathematical interpretation of this particular experiment which they have done, was not right. So the actual explanation of the photoelectric effect was done by the Albert Einstein. Now maximum questions are asked from this Einstein's theory. So let us first understand now the Einstein's theory, okay, of the photoelectric effect, the most important one in physics, and many questions are asked from this particular theory. So let us understand the Einstein's theory of the photoelectric effect now. So this is the Einstein's theory of the photoelectric effect, right? Or popularly known as Einstein's hypothesis. So Einstein have said what? That this is a metallic surface you have. This one is the metallic surface, right? What is your work? That you are going to incident some light energy to this metallic surface. Okay, here is the light energy which you are incidenting. This light energy is what? According to the Planck, h nu. Now, this light energy which you are incidenting will be again divided into two parts, not equal. These two parts are not same. One part, the first part, will be utilized in the ejection of the photoelectrons. In the ejection of photoelectrons, some energy will be utilized, and the other part of the energy will be utilized in the kinetic energy of photoelectrons. Right? In these two parts, this particular h nu is going to divide. So this h nu is going to divide in the two part. One is the ejection of the photoelectrons, right? And the other part is what? Kinetic energy of the photoelectrons. In these two parts, the energy is going to divide. So now he also explained the theoretical process of this. That first part of the energy which is required for the ejection of photoelectrons. For the ejection of photoelectrons, it requires some energy. So that energy is basically the work done to eject the photoelectrons. That energy is basically what? The work done for ejection of the photoelectrons. Right? So this work done for the ejection of photoelectrons is also known as what? This is also known as the work function. Okay, this is known as the work function, right? Okay, and he explained that work function should be written by this letter, that is phi. Okay, now this phi is always proportional to one of the special kind of frequency which is known as the threshold frequency, right? Threshold frequency. Now the question arises, this what is this nu zero or the threshold frequency? So threshold frequency is what? It is the minimum frequency. It is a minimum frequency, right? Required for the ejection of photoelectrons. Required for emission, right? Or the ejection of the photoelectrons. Ejection of the photoelectrons, right? Okay, that means your metallic surface, from the metallic surface, right, some photoelectrons will be ejected. Okay, when you will fall there, the certain special amount of light, okay, that frequency of the incidented light nu incidented, right, must be greater than or equal to the threshold frequency in mu zero. If suppose your light is like that your frequency is lesser than this mu zero or the threshold frequency, then the photoelectric effect is not going to take place, right? Okay, very important. So in the nutshell, he said what? He said that this phi is always proportional to what? Nu zero. Nu zero is what? The threshold frequency. So that means this phi or the work function, phi is also known as what? Work function, right? This phi work function will be equal to h times of nu zero, right? H again is a Planck constant. So first part of the energy he explained like that. Okay, the second part is what? The kinetic energy of the photoelectrons. So the formula of the kinetic energy is what? Half mv square. But here we don't know at which, by which velocity the electrons are traveling. That we don't know. Yeah, neither we are sure about the mass. So here what is going to happen, right? Because we don't know how much number of electrons are traveling. So here the very important part is what? That how to classify this kinetic energy now. So he said what? That the kinetic energy is basically dependent on one special physical quantity that is known as the stopping potential. Right? Stopping potential. Now, what does this stopping potential means? Stopping potential is basically the potential of this metallic surface, right? Every metallic surface has a property that there will be a certain amount of potential in the surface only that will obstruct the path of the electrons to get emitted. That means it is a potential which actually inherits the electric charge inside the metallic surface only. It will not allow the photoelectrons to get ejected. So obviously, that's the if you give the kinetic energy up to a certain extent with respect to the stopping potential, then the electrons are going to eject. That much amount of kinetic energy is required. That is all. So that means stopping potential is what? It is the potential, right, of the metallic surface that holds the ejection of the photoelectrons. Ejection of photoelectrons, right? So by the stopping potential, V will be what? That will be the total amount of the kinetic energy by the electric charge, that is Q0. And here the charge is what? Charge is equals to the charge on the electron itself. So V is equals to what? Kinetic energy by E. That means kinetic energy is equals to V times of E, right? Okay. This V you can write as a stopping potential. So that means the kinetic energy value here is what? V stopping potential, right, into what? The electric charge, that is E, right? This is the formula. Now I will write the Einstein's equation based on this theory, whatever we have done, right? That we have done what? The kinetic, Einstein explained that the energy is received, the entire energy which is received on the metallic surface will be divided into two parts. One is the ejection of the photoelectrons, other is the kinetic energy of the photoelectrons. Now the ejection of the photoelectrons, he explained like that it is basically the work done for the ejection of photoelectrons. Okay, the amount of energy utilized, and it is dependent on the frequency that is known as the threshold frequency, right? So it is equals to h mu 0, right? H is a Planck constant. For the kinetic energy, he introduced a term known as stopping potential. That means the stopping potential will inherits or hold the electric charge in the metallic surface. So if you give the kinetic energy same as the stopping potential, okay, then the electrons is going to eject from the metallic surface. That means the kinetic energy is what? Stopping potential times of the electric charge. So now I'm going to write the Einstein's photoelectric effect equation based on this very important equation of physics. Einstein's photoelectric effect, right, equation. Very important, last topic of the day. Okay, so what Einstein have said, that the entire energy h nu which is received is divided into two parts. One is what? The work function, that is phi. This is the work function. And the other is the kinetic energy of the ejected electrons, right? Ejected photoelectrons, I will say. So therefore, h nu will be equal to what? Phi work function plus the kinetic energy of the photoelectrons. So h nu will be equal to what is phi? Phi is basically what? H times of nu 0 here plus kinetic energy. Kinetic energy here is E V times of 0. Okay, V0 is what? V0 is the stopping potential. Or if you get confused, you can write here Vs also. Instead of V0, you write here Vs, right? Okay. So I will write here Vs, right? So Vs is the stopping potential. Okay. Therefore, your Vs will be what? Your Vs will be simply E times of Vs will be H times of nu minus nu 0. Therefore, your Vs is what? Your Vs will be equal to what? H times of nu minus nu 0 by E. right? This is basically known as what? This equation we have which I have derived for this stopping potential, this is known as what? Einstein's photoelectric equation. Einstein's photoelectric equation, very very important, right? Okay, so that means according to the Einstein, the entire this photoelectric effect, particularly if you see in the broader sense, right, the entire concept of the photoelectric current, prediction of the photoelectric current, is basically dependent on two things. One is the threshold frequency, that is of the metallic surface, that is the minimum frequency required for the ejection of the photoelectrons, and other is the stopping potential, right? Because in this equation, if you see, there are only two variables. One is the threshold frequency mu zero, and other is the Vs. Your nu is fixed because you yourself know that how much frequency of light you are incidenting, that you already know, right? So nu zero is a variable, and here is a Vs, the stopping potential is a variable. The stopping potential is what? Stopping potential is basically the potential which will hold or inherits the electric charge inside the metallic surface, right? Okay, so by knowing these two quantities, that you will able to identify that how much number of how much amount of electric current is going to produce, that you can identify, right? Now, dear students, this was just an introduction of the theoretical part of the photoelectric effect. So I would like to teach you more regarding this. I hope you enjoyed this class, right? And surely we will meet in the future classes, in the forthcoming classes. Doing some numericals also, good numericals of the competitive exams and the board exam both, right? We are going to surely do. One more thing which is important here is regarding the pattern of the board exam. It is completely changed. You already know this. This time the comprehension questions are also going to be asked. Those are the case study based questions. Same goes with the IIT and NEET also. They are going to start some maybe some of the very important questions related with the what can I say, the case studies. So those case study questions are very important for you to understand. And on this topic that is known as the photoelectric effect, which I have taught you right now, many case studies questions are also there. So that also we can do, right, in the forthcoming classes, dear students. Thank you so much. I hope you like this class from the mytutorsonline.com. I am Professor Jitesh Jain, right, your physics mentor. Okay, so shortly we are going to meet in the next classes, dear students. Thank you so much for your kind attention. Thank you so much. Have a good day. Good day, everybody.